Evening. I'm Rene Dena, and today we're going to be presenting our Project 3 for CS 4310, which we're given the task to set a priority application. The team members is me, myself, Rene Dena, Josephine Nguyen, and Nole Serrano. And to start off, I'm going to pass it to Josephine, and she's going to be explaining the main application, and then we'll go from there.
Okay, so as part of the assignment instruction, we had to change the PS application to also display the priority level so that when we do PS-L, it would also display the priority level. So in order to do that, we went to our bin folder and in the PS folder and went to processlist.cpp because that is in charge of the PS command. Then what we did was in the constructor here, we registered that flag -L so that we can filter what happens when -L is typed in. Then when that command is executed, we went through and asked, well, if we were given the -L, then we'll print out the header to also include the priority here. If not, then it's just going to do the one by default that's here. So that's in the else statement here. Then when we printed out the actual information in columns, we did the same thing and said, if we had that argument, then we're going to print out this and added this priority in there. Otherwise, this is the default code. That's essentially all we did to get the PS-L working. For part 3 of the assignment, we had to download the SC application so that we have the SC command. So that was the next thing we did, and we include that right here. And then we had to do the renice. So the renice was part of the assignment to redo the priority level. So we wrote an application called renice in that bin folder. And it kind of just mimicked the process list CPP. So we created here renice.cpp, and here it's kind of the same thing. So in the constructor, we have a description just like the process list.cpp. The only thing is that we're now registering positionals and the flag so that we know the arguments when the renice command is typed in. And then we have two global variables, the new priority and the process ID. We basically just said, make sure we save the first number as the new priority and the second number as the process ID. So an example, it's not here. Let me go back. An example here, when we type in the renice command, the first number is the new priority that we want, and the second number is the process number that we want. So because of that, we said index 2 would be the new priority and index 3 would be the process ID. Then when the command is executed, we just say, we're just going to print out just to double check that this is the process ID that we're using and the new priority that we're using. And we check to make sure that that priority is valid. So as long as the priority is between 1 and 5, so if it's not between 1 and 5, we're going to print that it's invalid. Otherwise, we'll say it's okay. Then we're going to use the set priority method of the process class to set that new priority. And then we'll have our Boolean to set true. And at the end, if that is true, then we just print a result. And then that is the end of that.
Changes had to be made to the kernel's API to access the modules found in the kernel's process H and process CPP files. For the process CPP, we had to change the process controls CPP file, which is the child of the API in the kernel. In the switch statement, which handles requests, a new case was added called getPriority, which follows the same structure as the other cases in the switch statement. Also under the info PID case, a new line is added where the info pointing at priority is added where it equals the proc pointing to get priority, and the purpose of this is to fetch the priority for verbose. And another case is added which is called the renice PID, which has the objective of the setting the priority to the process ID. And finally, under the log and operator module, the case for get priority and renice PID are added so that the program will be able to print the appropriate process operation to a log. For the process H, we had to change the process control H file, which is again a child of the API in the kernel. Under the enum in process operation, the enum operation of getting priority, named get priority, was added, and the enum operation of PID renice, named renice PID, was added. And also under the structure named process info, the priority level of the process was added, whose code followed the same as the state of the current process.
Evening, my name is Rene, and I am going to be presenting two parts. First, I'm going to be presenting part 4 of the project, where we are asked to create a priority-based scheduling within the systems library, and after that I will be demoing the actual implementation of our renice application. So let's go ahead and get started. So let's open up our code here. Within the library folder, we have our library POSIX and our library runtime. So these are the two only ones that we edited. So within our library POSIX, we have our sconce file. Here we just created a global path to our renice application, or our main CPP file, which is located within our systems folder. And here it is. But here's our application. But before we look at that, we can look at our header. Have a look at our header, which again we kept it simple. We have our renice process ID. That takes a few parameters. First is the process ID, second is the buffer, and then third is the new priority set by the user. So now we look at the main application. Again, verbatim, here it is. And the only difference here is that we have our process client, which is referenced. And so we set that. After that, we initialize a switch statement that checks whether the API is valid or invalid. So that's for that folder there. And then for our library runtime, if we open that, we have our process client. So here we have it. Basically, we have our set priority method, which takes the process ID and the new priority as the parameters. And within the process client main folder, or main file, I guess I should say, here we have our method being used, which is being referenced from the process client, as you can see here. And again, the method that is being used, that I'm referring to, I should say, is the set priority. So here it is, again, just taking in the process ID as a parameter as well as the new priority. So now we could go ahead and run the demo, to make sure everything's up and running. So we're gonna head into our directory. There it is. We run a sconce so we can make sure everything compiles correctly. Let me go ahead and pull up this right next to it. Okay, where are we at? Okay, so everything compiled successfully. So now we could go ahead and run FreeNOS. So let's go ahead and do that. Okay, there it is. So let's go and log in. And now we could test our application. So right here, we're putting it sleep for 30 seconds using the SC command, and then 300 seconds. And you're asking us to display the list, which we will then implement our renice application to give it a set priority of 2. So let's go ahead and do that. SC 360 as well as SC 300. So now let's go ahead and show our processes running. So here are two processes, 17 and 18, both are priority of 3. So now we want to change that. We're going to give process 17 a priority of 2, right? So let's go ahead and do that now. So renice NU, we're going to give it a set priority of 2, and that was for process 17, we said. So we hit that. Here we have a nice little verbatim display saying our process ID is 17, and we're giving it the priority of 2. Priority of 2 is a valid, because like you said, we wanted it to go from 1 to 5. So it says process 17 priority has now been changed. So let's go ahead and see whether that's true or not. So we run a process list, and let's see here. Here it is. Process 17 priority has been changed to 2. And yeah, that's pretty much it. Thank you for watching.